Good afternoon. So I'd like to give you a bit of vision about what the time machine is, what we've been doing, and what we will do. Depending a bit how you count, we can consider it's the 10th anniversary of the time machine. So the real thing started in 2014, essentially. And so I will try to give a bit of a perspective also in the next 10 years, so covering a bit of a 20-year period. And I will start first, before going into what we've been doing and what we will do, to introduce three metaphors, which are, I think, very important to understand what we're doing. The first one is the idea of the iceberg. Some of you are familiar with this one. The idea that the digital information currently available about the past is only a very small part of all the possible elements that actually could be used for reconstructing history. This part which is underwater, I call it the dark matter of history. It's dark because it's currently information which is latent. It's waiting to be discovered, to be created, to be visualized, to be transformed. It exists in archives, essentially, with very high quality information, very reliable. It exists in private archives, as Thomas was saying. It exists in many other forms that can be extracted. It's not destroyed, it's still there, but it's latent. It's waiting to be actually put in light. Most of this information has never even been read, if we talk about documents, by any current human beings. I mean, some maybe of our ancestors read it, write it, but many of the documents have not been read by any person who is currently living. So this makes it extremely important and extremely good. And that also means, because of the sheer numbers, that probably, despite huge effort in crowdsourcing and bringing people, it's going to be very difficult to extract and exploit this latent information without the use of, or at least the mediation of AI algorithms. And we'll see what we can do in that respect. The second metaphor, it's one of the first one we used on the time machine, is the information mushroom. It's barely saying that if you actually plot information density in time, starting from the present going to the past, you have a form of a mushroom. A lot of information in the last 20 years, very few about the rest. And what we want to do is enlarge this mushroom, making it a bit like a cylinder. And that you can do in various forms. You can do it by digitization. We talked a lot about it. And you can do it by simulation, extrapolation, trying to induce data out of the information you've been doing there. The thing which is important is that you understand that there is a cut. Despite if we do this, I mean, probably still information will be important for the last 500 years. But as we go into the Middle Ages and before, of course, we run to other type of information regime where it's going to be difficult to get the same level of density, where we'll be essentially basing on guesses and on simulation. But let's remember that 500 years period, because it's already a good objective. I mean, trying to actually bring the most we can do on the last 500 years. And the third one, which I think is very important and potentially interesting for our current discussion also today, is just thinking about a very simple idea. So you have two parents, you probably have 4 grandparents, you have 16 grandparents. So it's very easy as a calculus, the number of ancestors you have is 2 at the power n being the number of generations. Of course, that means you don't have any cousins that is actually making some children with other cousins, which in fact you probably have. I mean, maybe not directly your third generation ancestors, but probably some of your grandmother has something to do with another of your grandmothers. We'll see why just doing a couple of calculus. The only thing I want to show you is the effect of the quadratic numbers. So if it's 2 power n, and n is the number of generation, and n is, we consider n to be 25 years a new generation, we can make it 30, whatever. If we take this 500 years threshold I just mentioned, that means 20 generations. So it's a very small 20 generation. You can put the names of this generation on a single list. But if you do 2 at the power n, power 20, this is more than 1 million. That means that each of you has about 1 million ancestors in 500 years from now. So not 2,000 years, 500, 20 generations. Of course, it's maybe less if you're from a very small village where everybody is related. All your grandfather and grandmothers have something to do with one another. But if it's not the case, it's 1 million. So it's reasonable to say we would like to know something about that 1 million people. if we would be able actually to trace where they are from, to know more about their life, to progressively understand, I mean, how you relate to this million people, this not only would be very important for your own life, but it's also very important politically. I mean, our vision of the world is completely different if you would have conscious not about 2 generations, but about 20 generations. Because, of course, this million people, I mean, they've been in different places in the world, and that has an effect on your own identity. So let's keep these numbers here, and let's see what we can do about it. Some of the things are very basic, but very important. Others are potentially more ambitious. So one of the things which we've been doing since the beginning is the idea of automating that process. So this is a video from, I think, 2013, 2014, really the beginning of the time machine, we were trying to explain. So we were saying it's about automatizing the process of digitization, of extraction of information from document, and then of reconstructions of networks. So many of the things we've been hearing today. And the type of use cases we were saying at that point was full search. You would search for the name of an ancestor, Battista Nani, and I want to find all the documents that mention that ancestor. That seems very reasonable, very Google-like idea in its idea. For that, you need to be able of actually doing automatic extraction of information, and we started before there was all this progress on actually HTR neural networks with various type of approaches, including directly comparing the morphology of words, coming with association on the same page of the same words. But the idea is that that should be done automatically and potentially even without the intervention of human beings in a way or another, because you need to unlock this potential idea. Knowing that transcription in itself, and we may discuss that again, is not a goal per se. I mean, transcription, and we see that actually a lot of difficulty with transcription is only a mean towards actually realizing the social network of the past we just saw. So if we have this, that means that every document becomes a part of the social network. So here we take our example of Battista Nani. We have a tax declaration from Venice, and we have a part of his life, a snapshot of his life, which is showing essentially the type of person he was living in at a given period, because you need to declare that to the authorities when you're in Venice. And you do that very often because Venice needs a lot of money. So maybe a couple of years later, you have to declare again, and your situation has changed. A couple of children were born, you change places, another snapshot of Battista Nani life. Okay. Then, of course, you have some genealogical records, but not necessarily the one of church records. Here, Battista Nani is a noble person, so you get from Libro d'Oro its entire genealogy for free, because you get it, you need to prove he's a noble person, so you get it directly from there. And he's also an ambassador in Paris, so he's sending letters, and these letters he meets people. So all these elements are all relations, and we don't care necessarily about the rest of the text. We care about reconstructing that networks and making it grow, and as any of these networks, I mean, the more point you have, the bigger you have. So that initial idea, which you have seen a lot of examples actually arriving, has been deployed. And the other points which we had at that moment, the idea that big social network needs to be anchored into space, but for that we need, of course, to deal with the evolution of space itself. And so a lot of effort was in automatizing the process by which from document we can reconstruct temporal evolution of cities. Here, an example on one of the neighborhood in Venice, as it was modeled in 2014, with various things happening, building created, building destroyed, fires which are destroying a great part of the city itself, rebuilt and then redocumented, which is very important for us at that particular moment, and so on and so forth. And this is essentially the goal we have at that moment. How does that translate now? Oh, in different ways. First, through this year, we're going to actually release a very basic standard so that any information which is spatial temporal can be anchored to a document. Because in the end, independently of the type of application you want to do, this is a kind of common element. So it's the idea of a point of interest, let's call it like this, but essentially it means that your ancestor, or maybe somebody else, is mentioned in a given document and is mentioned to be living in a particular places, to have worked in a particular places, to have attended a particular event, and this is the point in space and time. As simple as this. And then you have a simple browser where you can actually search on a window and say, I want to display all the points between a year and another year, and then I want to be able of potentially accessing the corresponding document, zooming in, zooming out, searching maybe on a search engine there, and access to the particular line in a particular document, which is making the reference to the fact that that particular person at that particular shop, at that particular places. Very basic. It works with photos. It works with tax declaration, works with church records. It's a kind of global standards for which we're going to produce an open interface. And this is an easy element in which potentially there could be exchanges, for instance, with people doing genealogical trees and so on and so forth. Okay, so this is I would say, the baseline, the standard element, very important. If you could all agree on that standard, that would make things much easier and already boost things. But we had also other ambitions. I mean, to go slightly, beyond that just coordination aspect. On some of the proposal we actually submitted to the European Commission in 2019, which was for €1 billion project over 10 years, and for which Time Machine actually arrived first in all the categories. I mean, we were ranked not only in that document, we are in the 6th finalists of that competition, but actually we were the one with the highest score, 15 on 15 among the finalists. But there was a change, as you may know, in the program, and that funding proposal, that funding instrument was actually cancelled, so there were no billion proposals, and they decided to make smaller proposals. So that was the moment on which a particular community crystallized, was ready to make something that would be a game changer, but and had to continue without that huge money in the first place. But that created the collective moment we are still benefiting from today, and for this I will show a video which has a couple of years old, but which is showing all the people involved and the global idea, how we were describing it a couple of years from now.
The continent, Europe. In archives, beneath stones, in crumpled maps and winding streets, in pictures and paintings, in the depth of its green forests, history in Europe lies everywhere. How does one preserve and explore such a dense and fragmented past? How does one bring it into resonance with our contemporary world? In 2012, the Digital Humanities Lab at the École Polytechnique Fédérale de Lausanne launched the Venice Time Machine and offered unique virtual immersion into history, thanks to the development of big data and artificial intelligence technology. Since then, dozens of European cities have taken similar steps. Each now contributes to the creation of a unified temporal exploration tool accessible to all. All these initiatives are now gathered within a consortium that groups together more than 250 European partners, universities, archives, research centres, and also private companies. Time Machine participants include historians, engineers, geographers, developers, entrepreneurs, researchers from a variety of backgrounds, as well as ordinary citizens, defenders of their heritage.
Chaque ville du réseau de la Time Machine pose des défis particuliers. Et donc chacune des équipes qui reconstruisent Paris, reconstruisent Budapest, reconstruisent Amsterdam, Anvers, nous permettent de développer des compétences spécifiques.
I believe that the Time Machine is the future, how we will do digital humanities and humanities in the future. What we are striving after is really building things that are used to gain new insights.
First step, collect and aggregate data thanks to digital tools and automate everything in order to carry it out on a massive, quasi-industrial scale.
So we have all those data, we have to store that properly and manage it properly, but we also have to make sense of the data. If you just present to the people thousands of terabytes of data, it's meaningless.
Today, science and technology can profoundly transform the cultural heritage with an impact on research, education, new applications, economy, and society at large.
Il y a cette idée d'être capable de fournir à l'utilisateur final des moyens complètement innovants de naviguer évidemment spatialement, même si ce n'est pas aussi évident que ça encore aujourd'hui, mais aussi de pouvoir naviguer temporellement.
The past thus becomes an invaluable resource to develop new tools of knowledge, an essential testing ground to train algorithms and consolidate progress in artificial intelligence. The time machine will also provide Europe with a unique ability to preserve endangered heritage.
Il doit y avoir une prise de conscience sur le patrimoine qui doit au moins être comparable avec ce qui est en train de se passer sur la chute de la biodiversité animale. Quand un site disparaît, ce sont des pans entiers de connaissances que nous ne pourrons plus jamais utiliser pour comprendre le présent et anticiper le futur.
Preserving the past in order to withstand the test of time, but also to cope with the worrisome trends in living conditions on Earth, and respond to the wayward ideology affecting our times.
Notre rôle, c'est vraiment construire et mettre à disposition cette base de données, cette encyclopédie, exactement dans le même esprit que les encyclopédistes de la période des Lumières qui voulaient compiler des connaissances. Ben, nous, on cherche à compiler dans ce nouveau matériau qui est le matériau numérique, cette richesse culturelle, cette richesse sédimentaire qui décrit notre passé.
The race for the digitization of our past will not only be run by representatives of our public and scientific institutions. There is still a risk of seeing our history privatized, which raises the question of our society's ability to tackle such an issue.
You can argue that Google can do that better than anyone else, right? They have the best algorithms around. And I still think that it's crucial for Europe to do that on our own terms. If you imagine that an algorithm will only crawl those aspects of our cultural heritage that it finds most relevant to its advertisers, you only get a very partial idea of what the truth is.
This is an issue of culture, identity, politics, economics, and ecology. The Time Machine Consortium must convince European society to share in this project.
L'Europe est à un moment clé de son histoire. Et elle doit décider qu'est-ce qui est le plus important en termes d'investissement. Un des enjeux de Time Machine, c'est donner une possibilité d'ensemble négocier une histoire commune pour envisager et co-construire un futur.
Okay, so where are we from that particular vision? Well, first, there's the progressive transformation from that idea that we start from the documents and we actually organize the element to this idea of the digital twins of the mirror world. So each city, and more cities in Europe now, are getting equipped with a kind of model of themselves. So this is typically a digital version, typically 3D, with additional information. And what we're saying is that a city actually needs to be equipped with a 4D model of itself. That means that there is actually different version of the city, including, the version from a couple of years, and maybe the version of the future, in a sense that there are projects which are currently discussed, and they need to be integrated in a single information system. And essentially, this is what we call a local time machine. This is this concept we brought in the 2019 proposal, and that we organize with the idea that what the role of the time machine organization very concretely is to help the cities, a bit like a super topotech, if you want, to actually bring technology which is developed in an open way across Europe and elsewhere to be able of developing their local time machine. And this has been done autonomously by several cities, including actually Budapest, in the recent years, and showing that if you do and you go in that direction, you have extremely interesting aspect, not only in terms of knowledge, but in terms of effect on the creative industry and the management of the planning in various effect for scholarships and so on and so forth. And so the role of the time machine is to make this happen in both centralized and distributed way. And this is why we created the notion of local time machine. If you go to the timemachine.eu website, we'll see about 80 or 90 time machine, each of them having specific project, and this is getting updated on a daily basis, and it shows the way in which this actually consortium is taking shape. Part of the effort and on which people have been collaborating have been in in actually first and foremost developing new digitization methods. So there's some methods which are kind of standardized, although we saw also today that nothing, I mean, is always working from day one, especially if you work with ancient documents. But there's also a lot of ancient documents that need special design. So for instance, these are examples of a rotating table which was deployed in Venice to deal with cardboards, which are recto verso cardboard. This is not something you can do easily when you have to deal with normal planar scanners. And so if you develop a machine like that, once you can then deploy it in different places and deal with these cardboard system, which are extremely important. Some standard system exist, of course, for ancient documents that you know, like these ones, but there are also other systems for very big documents like maps, which are extremely important for the time machine, and that needs to be deployed on very large scale. So this is one thing. Another thing is actually, in particular at EPFL, we've been trying to get autonomous in actually this process of scanning the cities themselves. This is typically done by other actors, either the municipality or the people responsible for geographic information system, or Google. I mean, of course, Google Street View is an example of this, which has been pioneering. I mean, we wondered whether it was possible to develop with technology which were maybe cheaper and new systems that could be deployed in city so that the city can be scanned and that can be used as a direct material. So this is an example of a project that was funded by the Swiss scientific, the Fonds National Suisse, in which a new type of camera, which is based on a spherical mirror, could be deployed, and that particular car could be actually used to scan in continuous one of the city in Switzerland, in the same way we were discussing today with the archive here, that it's not that you want to want a person to actually scan your city, you want to be able to scan it in continuous and in real time. And some of our partners, you saw Yves Hubelmann from Econem, have been deploying more and more sophisticated techniques to scan sites and cities rapidly. And so this is the example of the city of Venice, scanned with 15 billion points by Econem, and from which we've been collaborating to try to transform what we were doing into something that goes into the heart of the model of the city. And you see that something new is happening when you have a full centimeter, a full model of a city with a centimeter resolution. So first you can take a normal 2D geometric map of the city with footprint, and you can just parse your model like this. That means that any of the building which is currently in the global model can be isolated and identified as a single entity on which you can refer. Second, you can do things like extracting all the facades of the city. So this is the work of Paul Guenek, which is a PhD student, which is showing how much actually when you start doing that systematically on a city like Venice, but the method is completely generic, so you can do it in any city of Europe, you end up understanding something completely different from what people have been doing in the study of architecture, because it's not about studying a couple dozens of monuments, it's about actually studying 10,000 facades. And this is interesting, and you can actually visualize that on a map. This is all the information we have from the cloud point. This is information which is on Wikipedia. So this is essentially public information about Venice Palace. You see only a couple of them. If you add all the books we've been scanning about Venice, you can actually extend a bit that to other elements, and so because there are things which are of course mentioned in the secondary literature which is not in the primary literature, but that is still very, very little if you compare to actually all the information which are in the archive. This is, for instance, the 1740 catastici. It's an equivalent of a census, if you want, which is covering almost the entire size of the city. And this is, for instance, the 1808 Napoleonic cadastre, very similar to many of the cadastres which are managed in Hungary and elsewhere, imperial cadastres, if you want, which are covering the entire information. That means that the density of information is really at another level from what is currently available in the primary sources and secondary sources for historians. So that means you can, on that basis, start to have a density of information which is automatically reusing elements to densify not only the famous places, but also the other ones, replacing the paintings, the engravings, and connecting everything with one another in a system where essentially the 3D representation is associated with the photographs which are taken on the ground, which are associated with the cloud points, which are managed, which are associated with the paintings, which are currently aligned, which are associated with the 3D model when they exist of about a given period, which are always aligned with the current version of the city, which is aligned with the cadastres, which are decomposing, for instance, here in 1808, the version of the city how it was in different shops, which are potentially aligned with the information which are in registers about who was in each shop, which can be parsed automatically. Francesco Raspi was living in this particular place, and it's linked here with one of the catastici from 60 years before. Another Raspi, probably his father or his grandfather, was actually having this particular shop. And progressively, using space, you integrate the information at a level which is completely new. So that now is a series of automatic tools. This is, for instance, what is done in Lausanne, combining the information, quite similar to what we have in Venice, to the current 3D map of Lausanne, but also the digitization of the various models of Lausanne in the past, and you can start working at that level of resolution. So really comparing in 3D the different models of the city and associating with them. So the point here, which is arriving, is on the one hand a very tight information system, but that's not the only thing. The only thing is that when you start to be at that level, you can start to have the cloud point as being the new georeference for the entire system. That means that if you take these as being your index and you divide it into a series of cubes, because one of the aspects which is interesting with space is that there's no clear notion of scale. I mean, you may be interested in understanding a series of information which are characterizing a full neighborhood of Budapest, or maybe a single street, or maybe a single building, or maybe a pillar in the facade of a building. And so that genuine multi-scalability is forcing a new type of system to be developed where we would actually be capable of generating various type of images for these various cubes which are constituting the texture of the structure. And on these, you could actually characterize them with various vectors. That means that, to be concrete, I'm dividing the space into smaller and smaller cubes, and for each of them, I'm associating information concerning images, text, elements from the past, elements which are textual information which is extracted, and all these through this new method, which are the equivalent, if you want, of ChatGPT, but for space, is creating a point in a vector in a huge dimensional space. That means that I have a characterization which is integrating all this information in a unified way. That means I will be able to understand analogies, similarities, to search, to use, the same way that there was this revolution linked with large language model, which permits to understand very wide contextual elements of a given word beyond, the sentence, beyond the paragraph, beyond the pages, but encoding discourses in a single vector. You can do that with space, in the sense that you would characterize what is the characteristic of that particular element, and you would integrate not only space, but all the information we have in time across that space. And this will completely change the way we are capable of dealing with this information. That means that, for instance, all this information we have now in other databases, there's a Topotheque, we have also this collaboration with Europeana, with their 60 million European documents, for instance, photographs, geolocalized. That type of geolocalization will be much, much, much easier and will be done fully automatic if we use that type of system, so that progressively we can bring this information which is not yet connected with the spatial temporal grid to a situation where it becomes available. If there is an information somewhere in an archive, which is European, which is linking with a street where one of your ancestors was living, that information should be put correct and integrated. That means that if you actually combine the information which are currently in the local time machine, the information which is centralized in Europeana, and bring a flux in which these elements are progressively reinforcing one another, you can make an integrated knowledge system, which first effect, it could take the form of a chatbot. Okay, That's the first element you get now that we use to ChatGPT. You say, okay, I would like a ChatGPT of history. So I would like to be able of saying, okay, how many, whatever, bakers were in that particular street in 1845, zooming on a particular place of the city at a particular time. Can you draw me a map of the city in 1905? Can you actually draw a general tree of that particular person? So that type of interactions, okay, that we start to understand what it is, because we use ChatGPT and we see when it's actually working, when it's actually not working, when it is reliable, not reliable. There's a lot of issue with this, but still, this is something which is coming in a way or another in that respect. The second thing, of course, is that that is only the tip of the iceberg, because chatting for a language model is in fact not an absolutely efficient way of using it. A language model is a simulator of language. In the same way, we're going to have a simulator of language, which is capable of essentially simulating any type of discourses. We can create the basis of having some form of simulation of space and spatial temporal elements. And that, we would like to call that a system like, we call it WELS for the moment, because it's a link with the time machine. It is a system that, if it's deployed as a foundational model, would have, of course, an effect on all the typical industries we've been discussing so far, cultural industries, creative industry, education, etc. But it also will transform completely the type of inner process we are currently doing in the time machine process, so that we do the reading, the identifying, the replacing, the imaging, the simulating, all these things, which is tedious process, which we are progressively putting into place, which we actually check whether they are correct or not, this building of genealogical trees, this transcription, translations, identification, name entity recognition, all that will change if actually there is a system like that. So I ask you for a bit of imagination, because I promised to do a 10-year fast forward. You need to just look the time at that past, how we were in 2014, how we are now, how we were actually in 2019 before ChatGPT and before what we understood large language model could do, where we will be in 10 years from now, where this type of system would actually be deployed, and what it would mean for the type of thing we're trying to do. It will need large computation, and that is something which is changing also a bit the rule of the game. I mean, the type of distributed exercise we have been doing in the time machine that Thomas was talking about, the Topotech, and this very lightweight, still web-based system may not be possible to deploy at that level. So the question is, if this is necessary, are we doomed? Or do we need necessary to have one of the big players in the world in that domain to be absolutely central in this process? Or are they way for public institutions, academic institutions, other groups that believe of some form of sharing and openness of information to actually organize themselves so that they can tap on that computational power? And so this is what we try to do in Switzerland, with the fact that in Switzerland we have one of the most powerful computing cluster in Europe in that respect. There's others in Poland, there's also in France, but that, for historical reasons I can explain, is extremely interesting. So, and the question is what to compute on that. And I think here we have a good example of what could be interesting of computing. So, to finish with, I think that just global calculation about this million of ancestors, which directly means something to me, is not so far-fetched. I mean, it's maybe something which, again, in 10 years, we actually would have a possibility of assessing and understanding in a way which is completely new. Thanks a lot.